Good afternoon. Welcome to today's lesson on section 6.5, which is graphing square root and cube root functions. So per your suggestions from the survey I gave back in December, I did make a worksheet that has everything all kind of laid out for the problems I want to cover, so you don't really have to spend quite as much time writing down the problems, but just see me work it out and then obviously writing down the solution. So we'll start with the most basic square root function you can have, y equals square root of x. Usually when you haven't graphed anything before, it helps to make a table. Eventually we want to get away from making a table, but in order to figure out the parent function, because that's what this will be, parent function for square root, we want to see how it looks. So if I plug in 0, I know y is going to be 0. I plug in 1, y is 1. Plug in 4, y is 2. So I think that's good. So you have 0, 0, 1, 1, and 4, comma 2. So the graph will look something kind of like this. Oh, I went too high. 4, comma 2. So the graph should look, again, kind of like that. When I ask for domain and range, now remember domains x, y, you're allowed to plug in. It has to be x is greater than or equal to 0, because you can't square root negative numbers, unless you want imaginary numbers, but of course we're graphing with a real coordinate plane. The range, which I haven't really talked much about, represent the y values that come out. So just by looking at the graph, we see that no y values go less than 0. So the range will be with y greater than or equal to 0. Because if you think about it, if you square root something, the answer is always going to come out as being positive or 0. So you can never have the square root of something be negative, unless you had a negative out in front. And just by looking at the graph, we see for ourselves that the graph's always rising, it's never dropping. Let's try another one here. Let's try y equals 1/2 root x. This, by the way, is example 1 on page 446 in the book, if you want to have the book open while you're watching this video. If I plug in 0, I still get 0. But if I plug in 1 this time, I get half. If I plug in 4 this time, I get 1. So 0, 0, but 1/2 and 4, comma 1. So it rises, but not quite as quickly as we would expect from before. Domain range still stay the same. And if you think about it, the way this compares to root x, actually, I'm going to do that down below. We say it's vertically shrunk by a factor of 2. I'll explain this in class tomorrow, but that would be what we would have, because you could see how all the y values are half the y values before. So it's vertically shrunk by a factor of 2. Okay, for number 3. So now we got quite a bit happening here. We have y equals negative 2 root x minus 3 plus 2. Well, here's the general formula for the square root function, where h comma k is like the vertex but really represents horizontal and vertical shift. And A, like before, represents reflection about x-axis, and vertical stretching or shrinking. So you could make a table if you want, but if we think about it, h here is going to equal 3 and k is going to equal 2. So when the original graph was like this, starting at 0, 0, for y equals root x, we now have to go 3 to the right and 2 up. So now it's going to start here. So if you want to make a table, I guess you could, because obviously I'm not going to plug in anything less than 3, and then I'm going to plug in values 4 or greater. So let's go back to the table here. If I plug in 4, work it out, you get 0. Plug in 7. 7 would be a wise choice because 7 minus 3 is 4, and root 4 is 2. So that would be negative 2. So 4 comma 0. So that's how the graph would look. Domain, obviously we have to go greater than or equal to 3. And the range, obviously we're dropping now because of negative, so it's going down because A is negative. And starting at 2, so we're going less than 2. So y has to be less than 2. Less than or equal to for that one. For the comparisons, obviously we go 3 right, 2 up. It is reflective about the x-axis, and it's vertically stretched by a factor of 2. We'll talk about this again next when we meet in class. So that would be the comparison of y equals root x. So that's how that graph would look. Okay, for number 4 through 6, now we're dealing with cube root. Now you can cube root whatever you want. So let's first put a few x values like 0, 1, and 8. And also do negative 1 and negative 8. Let's get 0, 1, 2. Cube root of negative 1 is negative 1. Cube root of negative 8 is negative 2. So the graph looks like that. So kind of like, actually I could probably do a better job. That wasn't that good. Okay, I wasn't that much better, but that's how roughly the graph would look. Domain range is all real numbers, because you can excuse me, you can cube root whatever you like, and the output will always be whatever numbers you can think of. This is from example 2 on page 447. Oh, and by the way, I forgot to mention number 3 is also from the book, example 4 from page 448, if you wanted to look at that example again. So I put 0 here, I get 0. Put in 1, I get negative 3. Put in 8, I get negative 6. So right now the graph will look something kind of like this. And if I plug in negative 1 and negative 8, I should get positive 3 and positive 6. Okay, that was a little bit better. So that's how that graph would look. And obviously we see vertical stretch by 3, and it's reflected about x-axis. Domain range will still be the same. Domain range for all cube root functions will always be all real numbers for both. You'll never see any problems there because you're cube rooting, you can cube root whatever you like. This right here is the parent function. For cube root. So how this compares is what I just wrote not too long ago. Because see how it does get stretched and it does get flipped over. For number 6, once you pause the video, work this on your own, and then play the video and see if you get the same thing. I'm going to work it out right now, but I really suggest you pause the video and try to see if you get the same answer. It requires a little discipline on your part, so you're not tempted to watch me work on this before you work on it. Remember, h and k, same thing, the general formula, which actually I probably should have mentioned before I told you to work on it, is the same as the square root y equals a, radical x minus h plus k, but the radical is now a cube root. So you should know what h and k are. Maybe that was obvious, maybe it wasn't, I don't know. Okay, that's how your graph should look for that one. And we see that it's vertical stretch by 3, 4 left, and 1 down. We need to do the comparison. Okay, so that concludes the video. Instead of having you do some Google Docs questions, I'm going to have you do some questions in the book. So look at our agenda for the problems I'll have you do, and then we'll talk about those problems in class next time we meet. All right, have a good night.